Chris Masterjohn, thank you for being back on the Genius Life for the third time, my friend.
Max Lugavere, it's great to be back.
Dude, you are my go-to expert for all things micronutrients and just nutrition in general. You're such a genius. And so I've been putting out, as I mentioned to you, these COVID-19 themed episodes of the show because I think this is, and rightfully so, it's a topic that people are very hungry for. There's a lot of confusion out there about what we should or shouldn't be doing in terms of supporting immune function. And you recently put out this incredible 44-page guide, the food and supplement guide for the coronavirus. So I wanted to have you on to talk a little bit about why you put this guide together and maybe some high-level actionable advice that you could offer my audience in terms of what they can be doing, what they can be eating, potentially even supplementing with to support their immune systems as we all go through this.
Yeah. So I think it's important to acknowledge at the outset that at the moment this virus just appeared out of nowhere over the last couple of months. So there exist zero randomized controlled trials testing anything that we can do for prevention. And even what's done in the standard of care and practice has no actual clinical trial basis to it yet. I mean, there's ongoing clinical trials of all the stuff they're currently doing. So no one really knows, and all we can do is, what there is a huge body of evidence on mechanistically how does the virus work, what is it actually doing in our bodies, and so we can dig into the enormous volume of decades of research on nutrition and herbs and foods and what they do in our bodies, and then months of research on, there's so much research coming out on COVID-19 that no one person could possibly read it all. I get up every morning and I look at the preprint site where all the articles that are destined for peer review are coming out before they're peer reviewed. Then they wind up on PubMed. There are dozens to sometimes hundreds of new studies on COVID-19 that come out every single day. So over the last couple of months, we have an enormous volume of COVID-19 research. And then we also know that it has known similarities to and differences from other viruses. So for example, the actual name of the virus that causes COVID-19 is SARS coronavirus 2. It is the sequel to SARS coronavirus, which we could now call SARS coronavirus 1, which caused the SARS epidemic back in 2003, 2004. And so it's 87% similar. And so, you can look at you can say, for example, that the way that this coronavirus enters cells is identical to the way that SARS coronavirus entered cells. But there's only one other coronavirus that enters cells in that way. Meanwhile, it's completely different from how influenza enters cells, completely different from how cold viruses enter cells. And then there's other basic things that where like all coronaviruses are lipid enveloped. Flu viruses are, cold viruses aren't. Or well, actually, some coronaviruses can cause colds, but the rhinoviruses cause most of the colds, and they're not lipid enveloped. So we can look at all that research and we can say, okay, what do we know about the way this virus behaves? What do we know about what worked for SARS and what didn't work for SARS? What do we know about what we thought might have worked for SARS and really tricked us because it was deceiving, right? So I think a few things that we can say are, number one, terrible idea to generalize from cold and flu prevention to COVID-19. There's certainly some things that are going to work for both, but it's a really bad idea because the way that they infect cells is completely different. And as an example of that, I have always recommended and practiced high dose vitamins A and D for cold preventions. There's really good research going back to the 1940s that if you take people who get 7 colds per year, so very high frequency cold sufferers, and you put them on tens of thousands of IU of vitamin A and vitamin D each, their cold incidence goes way, way down, right? So high dose of vitamins A and D are very protective against colds. There's a concept out there called the vitamin D hammer. As soon as you get first symptom, take 50,000 IU of vitamin D, boom, people say it, works like a charm for the flu.
Wow.
There's no clinical trials of that, but there's anecdotes for it. There are randomized controlled trials showing that vitamin D prevents the flu, right? So for colds and flu, really good evidence on vitamins A and D. However, we know a few things that should make us extremely cautious about generalizing from that to COVID-19. So first of all, part of the way that vitamin A protects against viruses is to be involved in the cell's ability to detect the virus and then mount an interferon response. And we know that the SARS coronavirus and the MERS coronavirus, and most likely the SARS-CoV-2, the virus that causes COVID-19, basically directly undermine the ability of vitamin A to stimulate the interferon response. It's part of like a really broad network where they have like a whole suite of mechanisms to evade and undermine the host from mounting an interferon response. That allows them to massively multiply, and then they wind up hijacking the interferon response at a later time to actually cause massive inflammation that contributes to disease.
So what is the interferon response? What is that?
So basically the cell will constantly monitor for signs of the presence of virus. One of the key signs of the presence of a virus would be double-stranded RNA, because when we make RNA, we're reading our own genome, which is made of DNA. We copy the gene and make a transcript of RNA that's a single strand that then gets read by a ribosome to produce a protein. So through our own normal processes, we don't have double-stranded RNA. However, a virus has to read an RNA template, hijack our machinery to produce an RNA transcript from that. So because the RNA virus is copying RNA to make a duplicate RNA copy, you wind up with the presence of double-stranded RNA. The cell says, "Oh my God, this is a virus." So the cell starts producing interferon, which is one of many small molecules called cytokines, and it is one of the key players in promoting the entire antiviral response. And so with most viruses, so this gets into a second thing to be real careful about generalizing. So interferon in general makes SARS-CoV-2, SARS, and MERS potentially very different from most other viruses. And this is most well studied in the case of the first SARS virus. So in almost every virus, interferon is very protective. The cell detects the virus, the cell mounts an interferon response, the interferon response mounts the entire immune response to crush that virus. Okay, so in the case of SARS, where this is really well studied, not only does the virus undermine, it literally has about 15 different mechanisms to undermine the cell's initial interferon response. That allows it to escape the immune system. It multiplies massively in the lung, but then it accumulates. All these cells called macrophages start getting recruited to the lung to try to deal with that virus, but they're late. They're like the fire department that got to the burned down house. Wow. And so those macrophages, once they build up to a very high level, at a later time point, they mount an enormous interferon response. It's way higher than what should have been there. And this late, delayed, massively overshot interferon response that came too late then initiates, is a major player in initiating what's called the Cytokine Storm, which is a huge burst of all the wrong type of inflammation that causes lung damage and ultimately causes death. So what I find to be one of the most compelling reasons to be exceedingly cautious about generalizing from something like the flu to something like COVID-19 is a mouse study that was done back around the time of the first SARS virus, where they engineered mice to delete the gene that is needed to respond to interferon. So normally, in most viruses, you would expect this to be very harmful because interferon is a major part of the response to crush the virus. However, as I just told you, in SARS, it can be completely distorted and flipped around. So what happened was, in these mice, when they deleted the gene for the interferon response, if they gave the mice an otherwise non-lethal dose of influenza, the mice died. Okay, so deleting the interferon response caused a non-lethal dose of the flu to become lethal. On the other hand, deleting the interferon response caused them to be able to inject an otherwise lethal dose of SARS, and the mice survived.
Wow.
So if you can have something as central to the response to viruses in general do the completely opposite thing to the lethality, to the risk of dying or not dying from the flu versus SARS, then the last thing we want to do is just assume that everything that worked for the flu will work for COVID-19.
Yeah, it's so counterintuitive because by deleting the gene that causes the mice to respond to interferon, it would seem like you're actually like deleting, in a sense, their immunity, right? But actually it showed that by doing that, they basically seemed to be, they were protected against SARS-CoV-2. Or the SARS.
So
not
this
COVID-2,
was
but
the
SARS-1.
this was the first SARS virus.
Yeah.
Right. And so what that shows is that, first of all, the thing with interferon is, first of all, the virus is evading it and suppressing it anyway. And so the natural ability. Now, okay, here's the question. What happens if it's suppressing it and evading it? What happens if you treat the person with interferon? Well, if the person can't make their own interferon, but you treat them with interferon, maybe that helps. However, that was a major treatment for SARS. The WHO contracted CDC to study all the treatments. CDC looked at the 3 studies on interferon and said inconclusive. Okay, now in China, they were treating everyone with nebulized interferon, but there's no studies on it. Everything that they've been treating people with, there's basically no clinical studies on it. So we don't know if it worked for SARS, and we don't know if it worked for if it's working for COVID-19 where it's being done. But what we do know is that the body's own ability to produce interferon is being undermined. And so you're not doing that much to hurt the initial immunity if you're deleting something that wasn't working anyway. But then if that thing is the thing that ultimately plays a role in killing you later, then of course deleting is going to help you out. So anyway, I mean, to pull it back to nutrition, that's basically a reason to be exceedingly cautious about jumping to conclusions from things that worked for other viruses to this one. And I brought up A and D, so I just want to make one final point. This COVID-19, this virus, is one of only 3 viruses out of all the known viruses that are known to enter cells by binding to a protein on the cell surface called ACE2. And ACE2 is a protein that otherwise has a completely unrelated positive health promoting function in the body. But in this case, it's the door that allows entry of the virus. And I looked for one of the things that when I was thinking about what do we do for nutrition is I screened everything that might be potentially useful. And I said, what does it do to ACE2? And so there are a number of animal studies on both vitamin A and vitamin D that suggest that both of them increase ACE2. Normally, that's a good thing. But when it comes to a virus, a good thing's not always a good thing because viruses hijack good things and they do bad things with them.
Wow.
So I've gotten a lot of criticism over this because people have said, well, we don't have clinical studies in humans showing that it's doing this. You don't know that it's going to worsen the disease risk. Of course, I don't know anything for a fact, and neither do you, and neither does anyone else, because there's no clinical trials of anything. So the point is, what do we do now? Well, at a very minimum, we rescind what would have been my normal intuitive response, which would have been to just like down lots of vitamins A and D. Right? At a minimum, we say don't take any more than you need to for other purposes. So I'm not out there saying everyone stop getting any vitamin D. Don't go outside because you might make vitamin D from the sun. But what I am saying is, be on the conservative side. If you are taking vitamin D for no particular reason, you should probably stop. If you were planning on taking high dose vitamin D to treat this, you should definitely avoid doing that. But if you have a problem that you're solving with 2000 IU of vitamin D, I'm not telling anyone to get rid of that, right? So if you have a good reason to be taking a certain dose of vitamins A and D, especially if it's for a medical problem that you're fixing, but if you have a tangible, perceivable benefit that you're getting from that, I think fine, stay with it. But on the other hand, if you're overshooting the dose on completely theoretical reasons, then I think I would say now is a time until we know more to be more conservative with that dosing. So I think that getting the RDA for these maybe going a little bit over the RDA for vitamin D since it's so controversial, but not going into the range of high doses and unnecessarily supplementing, I think is a very wise piece of caution to take right now.
What about for people that are supplementing with vitamin D to get their blood vitamin D levels into a certain range?
Yeah, so well, I would sort of take exactly what I said and then apply it to the range. I think that for vitamin D, I think there are a lot of people who are deliberately getting their vitamin D into the range of 50, 60, 70 nanograms per milliliter, which if you're in a country using nanomoles per liter, just multiply that by 2.5. And I think that the evidence is very weak for pushing vitamin D levels that high. In fact, I think there's compelling reasons to be cautious about pushing vitamin D levels that high anyway. For example, Reinhold Wief, who's one of the early people pushing the notion that we should raise our vitamin D levels that high, used Israeli lifeguards who had their 25-OHD in the 50s and 60s as a model of what evolutionarily we would likely have for vitamin D levels back when we were naked apes. Those Israeli lifeguards had 20 times the risk of kidney stones as the general population. And it wasn't just because of the vitamin D. They were sitting on top of, imagine lifeguards. Like, not many people climb up to the top of a tower, take off all their clothes and sit and bake in the sun. So they had some sun damage. They were a little bit dehydrated, but they also had hypercalciuria, which is too much calcium in their urine, which is a major risk factor for kidney stones, and which is a mechanism by which too much vitamin D causes kidney stones. So basically, like, from the beginning, there has always been reason to have caution around going up to 50 or 60 nanograms per milliliter. And so, I think that hitting 30 nanograms per milliliter is fine for most people. It's certainly going to keep you way outside the risk of any deficiency. Now, I acknowledge that there might be unusual cases where there's, a specific disease being treated with a higher level. If you have a medical reason to hit a higher level and you have evidence it's working, fine, that's one thing. But I think that I think if you asked me a year ago, I would have said that the evidence is pretty weak for pushing your vitamin D much higher than 30 nanograms per milliliter. Now I would say I would be extra cautious about pushing it higher than that.
Interesting. Yeah. I mean, there was that, I forget what journal, but there was that meta-analysis that found that people who had it within the range of 40 to 60 nanograms per milliliter seemed to have the lowest all-cause mortality.
Yeah, I have seen that. I've also seen lower estimates. So to be honest, I haven't kept up with that research. I'd have to go look at that paper and compare it to the other earlier ones that I'd seen that had different estimates.
But basically, I guess a good takeaway is that until the science clarifies, it's probably a good idea to not supplement with high dose vitamin D, but to continue to spend time in the sun as you see appropriate.
Yeah, and so to pull on a very brief tangent in a completely different direction, I think a lot of people, especially I live in New York City, where it's sort of like it's nuts here. 4,800 people dying every day. It's easy to be afraid to go outside just because you're afraid of the virus. And there was a recent analysis of the infection pattern on the Diamond Princess cruise ship, which went under quarantine. And before the quarantine, basically the virus spread freely across everyone, no matter where they were living. After the quarantine, the only people who continued to infect other people were the people who lived in the same room with each other, even though there was a central AC that was bringing 8 liters of air per second from one room to the next. And so I think that, that provides pretty good evidence that this thing does not travel that far in the air. And I think and also on that ship, the rooms on the outside of the boat had balcony doors that would open. So the ship is stationary. A lot of people have open balcony doors. The air could flow in and out that way too. So there was actually multiple ways of transmitting air from people. And so I think, one thing that I do is just for mental. We're basically in lockdown here, right? There's nothing open, nothing's going on in New York. Just for mental and physical sanity, I just go out every morning, and if someone's walking down the street, I kind of go to the other side, but I just make sure to get like 20 minutes outside in the sun and get fresh air. And so, same thing, like eat healthy foods that have vitamin D, get some sunshine. Don't go nuts on a theoretical basis believing you need to push your vitamin D to some theoretical area because it's going to have benefit. Like, there's lots of things that might be good for all-cause mortality. Even if it's true that 40 to 60 nanograms per milliliter is the best for all-cause mortality, and I'll look at that research. I'm not sure that's true, but even if that's true, not right now. All-cause mortality in New York City is usually an average 147 people total per day. There are 4, 5, 6 times that dying of COVID-19 right now every day. Who cares what all-cause mortality was driven by 3 months ago? It's right. If you in the outbreak in New York City, all-cause mortality is COVID-19.
Right. Wow.
Even if you don't have COVID-19 and you couldn't go to the hospital because everyone in there was COVID-19, you still basically got killed by COVID-19 on a population level.
That's a powerful way to think about it. Yeah. So vitamin D, and just to refresh the listener, it basically it works to increase the amount of these ACE2 receptors on the surfaces of cells.
Yeah. I want to make one more point because inevitably we're going to get questions on this. So many people have correctly pointed out that one of the things that happens to promote lung damage by the virus is that the cell starts making less ACE2 to protect itself against the virus. And because ACE2 is normally a health promoting molecule, that contributes to the lung damage. For example, ACE2 is strongly protective against fibrosis, which is the laying down of scar tissue. So the virus causes you to lose ACE2, and then that leads to lung damage. So a lot of people have questioned me on this and said, you shouldn't be trying to decrease ACE2 because the virus decreases ACE2. That's how it causes lung damage. I think this is completely wrong. So first of all, there was a mouse study where mice can't get SARS or SARS-CoV-2 unless you give them the human version of ACE2 because their ACE2 is different in sequence enough that the virus doesn't bind to it. When they give mice human ACE2, they can infect them with SARS. The more copies of the human ACE2 gene they give the mice, the earlier they die from the SARS virus. So even though SARS causes lung damage and death by decreasing ACE2, the more ACE2 you have, the earlier you die. So it remains a risk throughout the whole thing. Why? Because all of the problems, such as decreasing ACE2 that the virus might do, are caused by the virus infecting the cells, right? And what people don't realize is that if you increase or decrease ACE2 with a nutrient, you're having a linear effect. Increase 20%, goes up 20%. Decrease 20%, goes down 20%. Viruses, when they first infect you, grow exponentially. So if you have 20% more seeding of exponential growth, you're not increasing the virus 20%. You're increasing the base of the exponential growth by 20%. It's sort of like if you have a retirement account, putting $20 in today is not going to be 20 more dollars in your retirement. It's going to be way more than that, right? So if you put in 20 units of ACE2, you get seeding of that much more exponential growth. And the SARS virus that is then there at the end of the exponential growth will decrease the ACE2 a lot more than 20%, right? So even if you're in prevention mode, or even if you're infected, you still don't want to be trying to increase ACE2 because you're just going to increase the viral load of the infection. And that's what's going to drive the harm, even if the harm is driven by the loss of ACE2.
Makes a lot of sense. So there's a lot, I think initially people were thinking that ACE inhibitors might be helpful, but instead there's actually this paradoxical kind of effect that ACE2 inhibitors have, or I'm sorry, ACE inhibitors have. Yeah, ACE inhibitors have on the ACE2 receptor, which is how the virus seems to be able to enter cells.
That whole topic is a complete mess because there is no specific effect of any ACE inhibitors on ACE2, and the different ACE inhibitors have different effects on ACE2. So ACE inhibitors target ACE1. There are no ACE2 inhibitors. They don't exist. Even if they did exist, no one would use them. Well, I mean, they might be produced. There are things that are being produced for COVID-19 that block ACE2 for the purpose of blocking the virus. But in terms of blood pressure medication, no one takes ACE2 inhibitors. And right. even if you could develop a drug that targeted ACE2, you'd want to increase it for blood pressure, not decrease it. And so one of the things that complicates all this data is that what ACE2 does is there's a compound called angiotensin 2 that raises blood pressure, and it also does other things. It causes excess proliferation. It causes fibrosis, which is scar tissue laying down. So angiotensin 2 generally does a lot of bad things if it's in excess. The more ACE2 you have, you get less angiotensin 2, and you get more of a different compound, angiotensin 1,7, which counterbalances everything. So if you have angiotensin 2, quite often your system will respond by making more ACE2, so you can get rid of the angiotensin 2, raise the other protective compound, and counterbalance the system. But that's not so. These drugs, different ACE inhibitors have actually. So first of all, we don't know from any of the studies what they do to the cell surface expression of ACE2 in the lung. However, there are a number of studies that have been able to make inferences about what the different drugs do based on, for example, the amount of circulating angiotensin 1,7, which is the product of that enzyme. So, presumably, if the drug increases angiotensin 1,7, it's increasing ACE2. If it does the opposite, it's doing the opposite. So the different ACE inhibitors have widely varying effects on circulating angiotensin 1,7. What we infer from that is that every ACE inhibitor has to be taken on a case-by-case basis. And so what that means is that grouping ACE inhibitors together and saying, do they increase or decrease disease risk, is not a useful way to even start asking this question.
Got it. I was surprised in your food and supplement guide, you're normally a person who is singing the praises of liver from the rooftops.
Yeah.
But you're actually in your guide, you're like, maybe we should hold off on our liver consumption. Not to backtrack, but I mean, it's you basically make that recommendation for many of the reasons that we've already covered, right?
Right. So, I mean, my position is basically try to limit vitamin A to 3,000 IU per day. Okay. It's absolutely plenty for the next 3, 4, 5, 6 months, unless you have a condition that you're treating with higher doses. And the thing is, I actually am not eating zero liver. So I'm actually eating a fairly significant amount of ground beef that has liver mixed into it. But my total liver consumption is probably half a serving a week right now. I'm not adding liver capsules on top of the liver that I am getting in my food. And, I'm not eating a ton of eggs and butter. And when I eat more eggs and butter, I eat a little bit less liver, and it all kind of balances out. So what I'm saying is, if your normal practice for vitamin A is to eat 4 eggs a day, 3 tablespoons of grass-fed butter, lots of red, orange, yellow, green, colorful vegetables, lots of organ meats, and then on top of that, you're going to eat 2 servings of liver per week. Uh, I'm saying cut back. And so, either eat freely of eggs and butter, which have smaller amounts of the animal form of vitamin A, or eat 1 serving of liver a week, or mix and match at a lower level, but be conservative about it now rather than liberal.
Yeah. Okay. So we've talked about the ACE2 receptor. And just to make sure that it's crystal clear, don't go overboard with the vitamins A and D for that purpose, because that may create this upregulation of these receptors, which may
Right.
allow the virus easier entry into the cell. Then in the guide, you start talking about, and for those listening, I highly recommend picking up the guide because it goes into even greater detail. But of course, Chris is such an excellent communicator. He makes it really easy for all you guys. It's just really well laid out. But then you talk about once the virus is in the cell, minerals like zinc can basically help prevent it from replicating. Can we talk a little bit
Yeah.
about zinc and then also copper?
Yeah. So zinc and copper are doing two different things. Zinc inside the cell will inhibit two of the key enzymes involved in viral replication. Now, these enzymes require significantly more zinc to be inhibited than any of the essential zinc proteins that we need for health require to be active. Um, the amount of zinc that's in the cell is enough to inhibit those enzymes, but if you have, like, if you're at a zinc status where you could possibly have an otherwise beneficial effect by eating more zinc, you're probably not going to have enough zinc to inhibit those enzymes. So what we really want is to push zinc beyond the point where we've satisfied all the essential zinc proteins in the cell, and then we've pushed it up a couple notches.
Interesting. So zinc is actually a mineral that you might want to consume more of during this time.
Yeah, and I actually, I think that supplement. I don't think you can get enough zinc from food on this basis, and I also think that it takes a while. If you supplement with high doses of zinc, you don't absorb most of it, and so it really takes a while of supplementing with zinc to boost your zinc status. So I personally think that during this time we should be proactive about kind of getting the maximal safe amount of zinc.
From food primarily?
I think you have to use supplements to push it higher. Now, I think you can use food-based supplements. So, for example, you can use oyster capsules at high capsule numbers. But I don't think you can get zinc high enough to reliably inhibit viral replication without supplements in general.
Got it. And you offer like doses and like the types of the specific types of zinc in the guide. But I mean, just for like a 30,000 foot recommendation, like
Yeah.
what kinds of supplements should people be thinking about picking up?
Yeah, so you basically want somewhere between 40 and 110 milligrams of zinc per day, separated by 4 doses. So we're talking, 7 to max 30 milligrams per zinc dose. And you want them separated ideally across like 3 or 4 different dosings per day, because you absorb so much more zinc when it's spread out. And ideally, you want them on an empty stomach, but if that makes you nauseated, you can take it with some food, but you don't want to take it near sources of phytate, which include whole grains, nuts, seeds, and legumes. So either on an empty stomach or with a phytate-free meal. And I think any form of zinc is fine as long as it's not picolinate or oxide. I know picolinate is very controversial, but that's what I believe. And I think it would probably be a good idea to get a portion of it, some 20 or 30 milligrams as a lozenge, to increase the amount of zinc that reaches the nose and throat, because I believe that the nose and throat are probably the gateway to COVID-19 infection. Which is actually so this is one of the things I revised when I came out with version 2 of the guide. My initial impressions when this first came out were that we really wanted to target the lung. But the research that has been coming out over the last few weeks really indicates to me that the nose and throat are really ground zero for infection. And so zinc lozenges, particularly zinc acetate lozenges, the ones made by Life Extension, enhanced zinc acetate lozenges are the best. Um, those are the best way to increase the amount of zinc that's directly reaching the nose and throat tissue. Um, and so what I do is I take one of those zinc lozenges a day on a just prophylactic basis. And then if I have a potential exposure to the virus, which could be deliberate if I'm going to the grocery store, or which could be accidental if I, used gloves the wrong way, took them off the wrong way, or accidentally stuck my fingers in my nose when I know I shouldn't, or something like that.
We all do it.
Then I take the zinc after So if you know you're gonna, if you go to the grocery store, you know you're doing that. So I take one before, and I take one when I get home. If it's accidental, I just take one after, just as a means of keeping the concentration in ground zero of infection pretty high.
When supplementing with zinc, copper becomes particularly important. And
Yeah.
copper, not just because you're supplementing with zinc, but copper also plays another role in terms of the potential utility for the prevention of contraction of the virus. Correct?
Yeah. Yeah. So what copper, there's two things to consider about copper. What copper does directly to the virus is different from zinc. So copper does not seem to be very good at inhibiting viral replication like zinc does, but copper is toxic to the virus. And this is most clearly demonstrated by the fact that coronaviruses cannot survive on copper surfaces for very long. So on most surfaces, coronaviruses will survive for 5 to 9 days. On a copper surface, they survive for 5 to 30 minutes.
Crazy.
Yeah, so copper is very toxic to the virus. But the thing is, you're not going to get that effect from taking a copper pill, because it's a direct it's sort of like hydrogen peroxide. You're not going to drink hydrogen peroxide assuming that hydrogen peroxide is going to increase the levels in the lung and protect your lungs from infection. You're going to put hydrogen peroxide on something topically. Copper is basically identical to that. So I do have I have a copper-based nasal spray, Sterimar Stop and Protect Cold and Sinusitis. I don't know if you can get it now. So when I put this into the guide, there were 500 available on Amazon, and then I published the guide, and a couple hours later they were sold out. But they do seem to replenish their stock at least once a month. So anyway, I think that's the best product because it is designed to protect the mucous membranes of the nose, and I would be a little bit worried about spraying a high concentration ionic copper supplement directly into the nose. I think it might damage the sensitive tissues in the nose. So if you have the Sterimar Stop and Protect spray, I think spraying into the nose is good. Otherwise, like an ionic copper spray, you could spray it into your mouth. It tastes metallic and gross, but it's probably a little bit protective. But that's a thing where it's like it would really only be expected to be protective right around viral exposure.
Yeah, so if you've got virus hanging out in your nasal passages and you spray copper directly onto the virus, then you're saying theoretically it could kill the virus once it's there before it has the chance to invade.
Well, exactly. It's going to be toxic to the viruses that are like climbing out of one cell and into the next, and then they hit the copper and they're like, right. So that's that's one thing with copper. The other thing with copper is what you brought up, which is zinc can cause a copper deficiency, and you really want at least a milligram of copper for every 15 milligrams of zinc that you get, and so if you're supplementing with 150 milligrams of zinc, you want 10 milligrams of copper. That's actually the upper limit. So the upper limit for copper. So I do recommend trying to keep that ratio balanced in terms of you can get the copper from food or supplements.
Yeah. While we're talking about the supplementation of these minerals, is there any risk? Because it's like if you take too much selenium, you don't want to do that. You could obviously take too much iron, is there anything that people should be kind of cautious of when supplementing with zinc or copper?
Yeah, well, with zinc, the main concern is inducing a copper deficiency. but there is some evidence that it can decrease iron absorption. And so if you are vulnerable to anemia, it's possible that it could decrease your iron status if you're not co-supplementing iron with it. And then, of course, at doses that are higher than I'm recommending, zinc can make you pretty sick. But at doses that are under, in fact, 300 milligrams of zinc can basically stop your lymphocytes from being able to proliferate, which is terrible for the COVID-19 prospects. But at 150 milligrams or lower in divided doses that are no higher than 30 milligrams at a time, you're probably not going to run into much risk apart from copper and iron absorption issues, except for the risk of nausea. And in most cases, that can be dealt with by taking it with food. There are some medications that zinc interacts with, but they're at levels or they're at the they can each inhibit their absorption of each other. Let me pull up the link, not the link, the list that I have of those medications real quick. It's basically a handful of antibiotics, but hold on one second. Okay, so cephalexin, penicillamine, antiretroviral drugs, atazanavir and ritonavir, tetracycline, and quinolone antibiotics. Any zinc should be taken 2 hours or more away from those because they can either the drug inhibits the absorption of the zinc or the zinc inhibits the absorption of the drug or both. But besides that, zinc is pretty safe apart from those issues. Copper toxicity is a concern, but if your ratio of zinc to copper is 15-1, I really wouldn't worry about it at all.
Got it. Super interesting. Yeah, I've been looking into copper, and I was surprised to learn that copper is important for the production of melanin, which is the pigment involved in skin complexion, but then also hair color.
Yeah,
which is cool. Making sure that you're getting adequate copper may be
yeah,
a good way to prevent early graying.
yeah. Well, it hasn't done much for me, but yeah.
Okay, so this is all really, really crucial stuff. We talk then about, because we don't have that much time left, but you talk about elderberry. And, like elderberry is just one of those things that I didn't know anything about. And you see people kind of talking about it and you're like, elderberry? It sounds like some kind of homeopathic thing. So I don't know anything about elderberry, but if you want to just kind of shed some light on that.
Well, elderberry is an herb.
Okay.
And I mean, homeopathic doesn't mean anything to me because there's like things. So like the criticism of homeopathy is that it dilutes the thing down to a concentration that is less than existence. But there's things in a drugstore that are labeled homeopathic that are like there's zinc lozenges in the drugs that I can get at Rite Aid that are labeled as homeopathic but have 15 milligrams of zinc per lozenge. And so homeopathic to me is like if you are against homeopathy, you use the term to denigrate people who are in favor of homeopathy for being stupid. And if you are in favor of homeopathy, it's because you don't like conventional medicine and you'll buy anything that's homeopathic. And so I think these people are just betting that if they label it as homeopathic, more of the type of people who are looking for alternative medicine will buy it.
Sure.
So, I mean, to me, it's just sort of like, I don't know. So according to the main criticism why homeopathy can't work and is stupid, as long as there's some presence of elderberry in the thing, there's enough elderberry for it not to be homeopathic. So anyway, what we know about elderberry is it's an herb, and it's been shown to have antiviral effects in human trials for cold and flu. So about 700 to 1,000 milligrams per day of elderberry extract, which is roughly the amount of elderberry extract that would be derived from 25 grams of fresh berries. And believe me, it's like a nightmare to try to navigate through the different ways that different companies label the different products in terms of how they're standardized and what's in them.
Oh, yeah.
But I mean, this from the research, in the studies, if it's a good study, generally they try to quantify like how concentrated is the extract. So 700 to 1,000 milligrams of elderberry extract, the amount derived from about 25 grams of fresh berries, has shown to be antiviral in both cold and flu. As I said before, I wouldn't generalize from cold and flu. However, um, elderberry is very strongly antiviral towards human coronavirus NL63 in vitro. This is one of the only three viruses that enter the cell through ACE2. So SARS-CoV-2, SARS-CoV, and human coronavirus NL63. And one of the mechanisms that it's antiviral is that it directly blocks the interaction between the virus and ACE2. So that's a highly specific thing that presumably should generalize across those three coronaviruses. It also has activity against other coronaviruses by destroying the lipid envelope, and all coronaviruses are lipid envelope, so presumably that mechanism also generalizes to this coronavirus. So between the fact that it's strongly antiviral towards similar coronaviruses in vitro, and that it has a pretty strong track record of being antiviral in humans in clinical trials when it's been tested, then I think elderberry is a pretty strong candidate for an herbal supplement to take. On top of that, a number of people have asked me whether elderberry could be harmful in initiating a cytokine storm because there's a study showing that it increases cytokines when it's put on human monocytes. So I did a comprehensive review of all the literature I could find on this, and we can note a few things. Number one, in humans, there's only one randomized controlled trial of elderberry in humans, and it found that 1,000 milligrams of elderberry taken every day over the course of 12 weeks had no effect on the major cytokines that are increased in COVID-19. It actually decreased TNF alpha a little bit, although it wasn't statistically significant. Two relevant animal studies basically show that when you give elderberry to a healthy animal, it doesn't really do much to inflammation at all. But if you give the animal obesity or diabetes or something that raises inflammation, elderberry acts anti-inflammatory. And then in the cell studies, so in COVID-19, we are primarily concerned with inflammation being initiated by macrophages in the lung. And in macrophages, elderberry is consistently anti-inflammatory. Also in COVID-19, worst cases have higher neutrophil counts. Elderberry inhibits neutrophil activity. And all of the studies showing that elderberry increases cytokines is in monocytes. And monocytes are not a cell that's directly implicated in the cytokine storm of COVID-19. So I think the balance very strongly favors the idea that elderberry, if it does anything at all to the risk of a cytokine storm, it would probably have an anti-inflammatory effect. But more to the point, it would probably be antiviral, and viral replication, viral infection, and high viral load is the major thing that's driving the cytokine storm. So I think anything that is antiviral is probably going to be very positive for the cytokine storm outcome. And elderberry is not something that it has its main viral activity by stimulating those cytokines. It's something that is directly killing the virus.
Wow. One of the components of elderberry is caffeic acid, and you talk about how caffeic acid seems to be able to bind to the ACE2 receptor to prevent viral docking. I think it's super interesting. When I read that, I thought it was super interesting because strawberry leaves were actually fairly recently discovered to be a really potent source
Oh,
of
the leaves. Interesting.
Yeah, the leaves. So people always cut the leaves off and they throw them away. Strawberry leaves.
Do you eat the leaves?
They don't taste great, you know. It's not like they're not like kiwi. For example, I love kiwi skin, like the skin on kiwi, because I think the skin adds a very good tart flavor to the sweet fruit. Strawberry leaves are kind of, I wouldn't call them good necessarily, but yeah, they're a great source of caffeic acid, which we know has a number of benefits. In the time that we have remaining, I want to talk about vitamin C, because that's another one of these micronutrients that always comes up in the conversation. And then would love to close, if we can, on just your sort of overarching dietary pattern your thoughts on like an overarching dietary pattern to adopt during this time, because there's a lot of talk about the role of blood sugar in in helping increase comorbidity and or sorry, increase morbidity and mortality for the condition. So just like your overarching dietary pattern thoughts. But we'll
Yeah.
start with vitamin C.
Okay. So vitamin C, I think, is quite a difficult topic. Um, so first of all, there's been a lot of talk of the use of vitamin C in China, use of vitamin C in some New York hospitals. There is basically no evidence that anything that they're doing for this disease does anything. I mean, they're doing what they can and they're doing what they think might help. And it's a level of crisis that is so exceedingly crisis oriented that no one is collecting the level of quality of data that that can tell you that can carefully tell you what works and what doesn't. And just now, so like for example, in China, they were treating the standard national protocol guidelines called for using chloroquine, but they just now, when the Chinese epidemic is supposedly over, just now the randomized controlled trials are coming out on hydroxychloroquine. They're consistently coming out negative. And so, like I said before, in the SARS epidemic, they were using interferon, but like it was a decade later where they looked back and said, "Is there any evidence this works?" No. So I don't think we know now whether vitamin C is working in those contexts. We do know that vitamin C is beneficial for the immune system. We know that vitamin C is necessary for the immune response in a number of different ways, both as an antioxidant and in some other ways. And we do know that at least in acute respiratory distress syndrome, that is not specifically tied to SARS or to COVID-19, there is one trial showing that intravenous vitamin C cut the mortality rate in half from acute respiratory distress syndrome. In that paper, no one was listed as coming from SARS, and that was done before COVID-19. So my concern with vitamin C is that if you look at the different studies that vitamin C has on interferon, it has wildly conflicting effects on interferon depending on what model it's studied in. And because I think interferon is very much a wild card in this disease, I'm very hesitant to adopt high doses of something that is aimed to have an immune supportive effect by stimulating interferon. So I think high dose vitamin C is a complete wild card. I think it should be studied. I think it's possible that intravenous use of vitamin C is helping people in some contexts in critical care. But that's something that, first of all, it belongs to the realm of critical care, and then when the time is right for them to be able to do careful randomized controlled trials, they should do randomized controlled trials of what it's doing in critical care. I think that in the short term, what we want to do is get enough vitamin, from a preventative effect. I think we want to get enough of the normal dose of vitamin C that maximizes normal, healthy immune activity. And so that is, you're probably getting most of the benefit from 80 to 90 milligrams a day. There's some indication that up to 150 milligrams a day is going to give you a little bit of an extra benefit in terms of normal, healthy immune function. So I think just eating vitamin C rich foods that give you 100 to 150 milligrams a day of vitamin C is the best thing to do. That basically amounts to, fresh fruits and vegetables in most cases. Carnivores have to eat organ meats and stuff like that. They're probably not going to hit that high target and whatnot. But I don't think it's a good idea to be taking like 3 or 4 grams of vitamin C as a preventative effect. I'm not saying it's bad. I'm not saying it won't help, but I just think it's way too much of a wild card. I could go 50-50 on whether that's going to help or hurt. And so just limit it to healthy normal levels of vitamin C, in my opinion.
Yeah, if you guys listening go over to my Instagram page, about a week ago, I put up a post highlighting different types of produce that have more vitamin C than an orange. I mean, oranges are great. I'm eating about like 1 or 2 sumo oranges a day. Have you tried the sumo? They're incredible. sumo
I haven't tried.
oranges. They're
No.
awesome. I think my favorite thing about them is how easy they are to peel. But oranges are not the end all be all source of vitamin C in the produce department. You can get bell peppers, which are amazing, broccoli, strawberries. I mean, if you consume strawberries, you're getting about 85 milligrams of vitamin C in a cup, and then if you eat the leaves, you're getting that caffeic acid on top of that. So, strawberries, kiwi, kale.
Yeah.
Um, all right. So, in terms of just like dietary pattern as a whole, do you have any? I mean, any
Yeah, I
thoughts
mean,
there?
as a general pattern to the diet, I don't really think that there's much reason to deviate from what we would normally consider a healthy diet with COVID-19.
Hmm.
I do think that as we've been talking about, there's things we can add to try to get more zinc, for example, get enough copper, for example, add some herbs in there. Don't go crazy with some of the supplements you might normally go crazy with. But I really don't think that I don't really think there's a basis for saying like what constitutes a healthy diet has changed. And so to me, that means like eat enough protein, generally half a gram to a gram per pound of body weight for most people. You can go on the higher end if you are, have a fitness goal. Right now, that might mean that you have a very high quality home gym. Go on the lower end for just basic health and diversify that across whatever you tolerate and whatever you're ethically willing to eat in terms of meat, fish, shellfish, dairy products, eggs, etc. If you're a vegetarian, legumes are probably going to be your go-to for protein. And then eat a lot of fruits and vegetables, diversify your starches, legumes, grains if you tolerate them, starchy tubers, etc. Make sure you get your greens in.
Vegetarians
Basic,
and
basic.
vegans should be particularly cautious because all those foods that you mentioned can inhibit the absorption of zinc.
Right. So, I mean, yeah, probably someone with a zinc deficiency or with just marginally low zinc status, I would think all things being equal, they're going to be a lot more vulnerable to infection in general. Well, I mean, it's known that they'll be more vulnerable to infection in general, and I think they'll be more vulnerable to this infection. I think you can get around that. So, like, I think a vegan who has strategic zinc supplementation is probably going to wind up with better zinc status than a vegan who says, "Oh my God, I got to try to get some of the least conscious fish into my diet somehow," and starts eating like a clam a day. So I mean, it's not the be all end all, but yeah, certainly vegetarians and vegans are going to be at greater risk of zinc deficiency. I think that's true.
Great. Well, we're out of time. Thank you for coming on. Just to recap, just to make it all super clear. We've talked about vitamin A and vitamin D. If you're taking mega doses, you definitely want to cut that out. Your guide is super, super complete, so I think people should definitely go and pick that up. But at a high level sort of triage approach, you would say, zinc, super important, copper, super important. These are things that you could definitely add. Elderberry potentially. Is there anything else that you think is like a, low-hanging fruit for people to stay safe during this time?
Um, Garlic is interesting. I think that garlic is a little bit less compelling than the elderberry and the zinc, but garlic has some convincing antiviral activity in humans, and there's some less compelling, but still pretty reasonable to speculate that garlic would have antiviral activity here. And I take 180 milligrams a day of stabilized allicin, but you can get the same if you have a well crushed clove of garlic or a quarter teaspoon of garlic powder that you mix with water that you then let stand in the open air for 10 minutes. And you can mix it with anything you want that isn't acidic, basic, or oily. So unfortunately, the allicin is probably destroyed by olive oil, and it's destroyed by anything that does major changes to the pH. But other than that, if you want to mix it into some kind of that rules out a lot of sauces.
Well, what about like stomach acid then?
Um,
Like when you consume it?
yeah, good question. I don't know. So the absorption of allicin is like really confusing because it it uh it get like it's not ever detectable in the blood, and the only way to measure its absorption is to look at the amount of I think it's no, it's allyl methyl sulfide that winds up in the breath.
Hmm.
And I don't know. So outside of the body, they've shown, and I'll have to look at this more deeply. Maybe it's the case that if you mix it very quickly with the acid and it takes time to degrade the allicin. I just know that in um, in humans, when they feed it, it gets absorbed. But in vitro, when they treat it with things, pH things cause it to degrade. So it might be a matter of time.
Hmm.
Maybe it's the case that you can mix it with those things if you don't store them in the refrigerator and you just consume them immediately. I'll have to do some more research on that, but that's a good point.
Yeah, I mean, in the guide, you say 1 clove of fresh raw garlic crushed, exposed to open air for 10 minutes. What if you crush it and you assume that it's going to take 10 minutes to make its way into the small intestine? If you're eating it on an empty
Oh,
stomach.
I wouldn't count on that because I don't think you're going to have the same kind of air exposure.
Got it. So it needs exposure to oxygen
Yeah.
or whatever. Super interesting. I mean, eating all that fresh raw garlic, you're going to be happy that you're self quarantined. Um, by
Yeah. Well,
by
if you're a garlic lover, for sure.
yeah.
Thank
Well, dude, thank you so much for coming on. Always
you,
love
Pat.
talking to you. I always learn, lots and lots from you. And where can listeners find you on social media if they want to connect with you, follow you, have follow up questions, etc.?
Yeah, I'm at Chris Masterjohn on Facebook, Instagram, Twitter, and YouTube mostly.
And where can people pick up the food and supplement guide for the coronavirus that you've put together so
Yeah,
beautifully?
it's at chrismasterjohnphd.com/coronavirus, and I'm sure you can just give people a link for that.
Dope. All right, you're the man, dude. I look forward to the next time that we can hang in person. And
Yeah.
can't wait,
Who
dude.
knows when people are going to see people in person at
I
this point?
know. I'm excited to wear my jeans again and to like go outside to put. I haven't like worn. Yeah, yeah. This is crazy. To all you guys, I hope you're staying safe. Check out Dr. Masterjohn's work. He's the man. Text me to let me know what you thought of this episode. My number is 310-299-9401. Share this episode of the show with your community. It's going to do a world of good for people that that listen to it, obviously. And I will catch you on the next episode. Peace, guys.